YouTube, welcome back. Given a non-negative integer called x, find its square root rounded down to the nearest integer. You are not allowed to use built-in functions like Math.sqrt or any other operation. So one of the things that we can solve this problem by using a binary search algorithm, like we can use two pointers, left and right, and left to start as 1 and right start in x, and we try to calculate the middle number, which will be like for example, let me just try to type it here. So left will be equal 0, and let's assume x is equal to 4, for example, and right it will be equal to that x, and we start to get middle, so it will be 0 plus 4 divided by 2, which will get us to 2, and we will discover if the new middle, if we multiply middle by middle, so 2 by 2, if it equals the x, which is 4, we return the middle. If the mid is less than x, we move the left pointer to the mid plus 1. If mid multiplied by mid is greater than x, we move the right pointer to mid minus 1 in the search. And yeah, this is how it works. So let's just delete everything here and start working. So I will just create a base case because x could equal to 0. So if x equals to 0, return 0, and I will head let left, which equals 1, and let right, which will equals to x, and we'll create a while loop while left should be smaller than or equal to right, and I would say let mid equals math.floor left plus right divided by 2, and I'll say if mid multiplied by mid equals x. If that was a case that we talked about, we return mid, and else if the mid multiplied by mid, okay, let's just say that let's call this let target, or let results like res, and I would say instead of mid multiplied by mid, because we use it a lot of times, so res, if res equals it's less than x, we will say we will look for larger values, because if x less than that, we'll look for larger values, so we should move left. So left should equals mid plus 1, and else, which is the end one, if basically the rest is bigger, so we need to look for smaller values. So right should equals mid minus 1, and if we couldn't find anything, we return right, and see how this will work. Let's run it. Let's see the tests. Did work. Let's submit. Okay, we're beating 82%. It's not bad. It's pretty good. So yeah, it was a pretty simple problem to solve, and yeah, that's it for this video, and see you in future videos.